Okay, so I quickly want to go through a couple of examples for section 1-7. In this section, we talked about the midpoint formula and the distance formula. So for those of you who weren't with us in class, here are two representations of the midpoint formula. This first one is for if we just have a number line, just like the x-axis. It's just the midpoint is at the average of the two endpoints. And really that's represented here as well, which is what we use when we're in a coordinate plane, x and y axis. The x-axis, again, just that number line, so the midpoint is at x1 plus x2 divided by 2, the average. And same thing on the y-axis. And so that then allows us basically to find the midpoint on the y-axis, the midpoint on the x-axis, which then shows us where the midpoint will be on our actual segment we're looking for here. So let's go ahead and do an example. I want to do a couple examples that are on the back side of your notes. So first off, looking at, let's go ahead and look at this example here. Line segment RS has the endpoints at 2, 4, and -1, 7. What are the coordinates of the midpoint? Well, I could look at the coordinate plane, but since I don't have one here, I'm going to go ahead and just sketch what's going on here. So they tell me I have R and S, and that my coordinates are at 2, 4, and at -1, 7. I want to find the coordinates of that midpoint, and I don't know what those are, but remember a midpoint is right in the middle. So what we do, we say the midpoint is at x sub 1 plus x sub 2 divided by 2. And again, the subscripts here, the 1 and the 2's, are simply saying that we have x and y coordinates from different points. So the first point versus the second point. And now we can go ahead and plug in. So the midpoint is going to be at 2 plus -1 divided by 2, comma, 4 plus 7 divided by 2. So our midpoint is located at 1/2, comma, 11 halves. And yeah, that looks like a nasty number, but again, that's where it's at. We could find that point on the coordinate plane. That would be at 0.5 on the x, and then 5.5 on the y. Next, I'd like you to look at the distance formula. And again, in your notes, here's the example of that distance formula. So our distance is going to be the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And I want to do this example sitting right here. We're just going to find the distance between S and R. So looking at the distance from S to R, we are going to say then SR equals the square root. And now if it helps you, you can go ahead and say, all right, this is my first point, so there's x sub 1, y sub 1. Here's my second point, so here's x sub 2, y sub 2. And then we plug into that distance formula. Oops, change my color here. So x sub 2 is 3 minus x sub 1 is -2. Watch your negatives. It's squared. Plus y sub 2 minus y sub 1 squared. And so we have the square root of 5 squared plus -15 squared. And so this is the square root of 25 plus 225, or the square root of 250. Now we're going to have to grab our calculators to find out what that is, because they do want us to round to the nearest tenth. And according to my calculations, that is approximately 15.8.